and welcome to week 5. So for this week, we'll be working with data visualization. This is a new part to our pipeline where let's do a quick recap. Where basically in the first week we taught you how to use Jupyter Colab notebooks, how to get used to it, accustomed to it. You filled out a survey for it. For then in week 2 and week 3 we worked with the basics of Python, how Python data structures work, what are lists, what are dictionaries, what are tuples, then what are integers, what are strings, and what are decimals, and how these actually function, in the Python programming language world. We use simple fundamental concepts of programming, such as if loops and then for loops, and they overall they give you a pretty decent insight on how this language works. Um, the good thing about the libraries that we use is that they build on top of each other. So a lot of the nitty gritty work that you would have to do before, it's not necessary now because the libraries make your life very easy. When speaking of libraries, during week 4, what we talked about pandas as pandas library, and what it does is it helps us load our data set into a format called data frame. In our case, we're working primarily with CSV files. CSV files are the most common form of data, one of the most common formats of like data sets used for analysis. There are some other types like JSON, but they're all very easy to use with Python too. So that's the cool thing about it. For the curriculum, we're focusing on CSV specifically because of its relation to the curriculum. Um, so a quick thing about CSVs. CSVs are comma separated values. So if you open a CSV file as a text file, you'll see that every value is separated by a comma. And at the end of the line, if there is no comma after a value, that means it's a new column. So that's a very basic structure and people were very smart on how to use it. So we also taught you basic form functions inside pandas for the data frame, such as dataframe.loc, which is locate, dataframe.indexLocate, and then we cleaned our data set by using the df.drop_na methods, which is basically clearing out null values in our data set. So all these three are very crucial to the foundation we are building, and you'll see that they go very, very, very much in hand with visualization methods that we'll be using. So throughout this notebook, we'll be going through on why data visualization is so useful and how to simply implement it. And from a very basics point of view to all the way a bit more, not advanced, but a bit more convenient method that has some back-end extra engineering, but you won't have to worry about it. So let's go below. So what is data visualization? So data visualization is where a given data set is presented in a graphical format, and it helps us in detecting patterns, trends, correlation that usually go undetected in text-based areas. In simple terms, we primarily use data visualization to explore data and to communicate data. The next question is, why should we use data visualization? I think most of you, everyone who's looking at this probably has used data visualization at some point in their life. So it's a very integral part of our way, of working or functioning in the world, in one way or another. Even our eyes, they visualize data. So that's an interesting science on its own. So as the world becomes more connected due to an increasing number of electronic devices, the volume of data, of course, will also continue to grow at an unprecedented rate. And data visualizations make big and small data sets easier for the human brain to understand and visualize. Uh, and which also again makes it easier to detect patterns, trends, and outliers in groups of data. It's honestly really important for any career. For teachers, it's trying to make sense of student test results. For examples, for computer scientists trying to develop the next big thing in artificial intelligence, and they're collecting the data they get from the computer, and then they visualize it to see, okay, is our computer heating up, or how is it performing? And it's hard to imagine a field where people really don't need data to better understand their field. So how should we use data visualization? So good visualizations should place meaning into complicated data sets so that their message is clear and concise. So for example, when you use a basic bar graph or an integrated infographic, data visualization makes large amounts of numbers and statistics accessible to both business holders and their audience, or just researchers in general. And it can and should be used to influence our decision making, which is known as data driven decision making. And actually, it's very important when you're trying to analyze and implement strategies to improve. For example, a website, for example, let's take Facebook, right? Their data is collected and then it's visualized to extract meaningful information out of it. Like that's how their HR market departments work. That's how their marketing departments works. That's how most of their department works, and most of the companies, that visualization is a very important tool, part of their toolkit. So yeah, they visualize charts and graphs instead of skimming through the cluttered data, and visualization makes it very easy to ensure that like for example, Facebook's website is as optimized as possible. In other cases, data visualization can also help you ask the right questions, and it makes more data more memorable for stakeholders and researchers, or people who are working in as a job as a data analyst, because it's literally more easy to remember visualizations than just looking at data on its own. So let's talk about the data sets we'll be using for this notebook. So we'll be working with a stock market index, which is a data set that contains 5,473 rows and 10 columns. We usually call rows items. One item is one row, but it's not doesn't have to be necessarily uh, it's flexible, that term. So the first row is the header, and therefore the shape of our data set is 5,472 rows and 10 columns. And the first column is also the datetime ranging from 1990 to 2012. The remaining 9 columns are numerical values that indicate the stock market prices of companies, such as these are names of the companies. I'm sure you can guess the name by just looking at the initials for them. So the next data set is the California housing information. This is a very interesting data set because a lot of people use it just when they're getting started into more advanced data analytics. But it's also probably one of the most simplest data sets out there for good visualizations to actually understand how visualizations work. Um, they're good for a lot of disciplines of data analysis. So if you want to read more about the data set and how the information was collected, you won't have to, but it's just good to know. I guess it's useful information. I will be attaching resources at the end of the notebook. So this data pertains to the houses found in a given California district, and some summary stats about them based on the 1990 census data. It's old school, but it's collected in such a manner that's very useful. And the columns are as follows, and their names are self-explanatory. Longitude, latitude, these are two interesting columns that we'll be working with. So let's look at the goals. So we'll be building a plot step by step using Matplotlib. We'll be loading datasets using pandas and visualizing selected columns from that data frame. We'll use a stock market index to visualize trends in data from 1990 to 2016 for 6 listed companies, which will be just basic plotting. We'll be plotting them just to see, how much more, how nice we can make them, how useful we can make them for us. So breaking down the matplotlib function, pyplot.plot, this is a very interesting function. That's pretty much one of the most important function for matplotlib. And we'll be introducing to pandas. We'll be introducing to figures and subplots, colors, markers, line styles, using matplotlib and pandas side by side. That's the cool, interesting thing about them. So we'll be using text labels and legends, and there'll be 4 now try this questions for this part. Then we'll move on to plotting relational graphs such as bar plots, histogram, line plots, scatter plots. And we'll also be using the tutorial. We'll be moving on to a tutorial section where, when I mention longitude and latitude data, we'll be plotting those out and getting useful insights. This is the grading method. Please follow this if you're a part of the course. It'll be it's very self-explanatory, and it's similar to what you've done. It's the same as what you've done before. So moving on to Matplotlib. The Matplotlib library is a Python 2-dimensional plotting library, which means simply X versus Y. And it allows us to generate line plots, scatter plots, histograms, and bar plots of the values that we give it. In our case, we'll be using a specific set of functions in matplotlib.pyplot, like I mentioned. And we can find more in-depth information about Matplotlib if you click on the link, you'll be directed to the documentation link. So Matplotlib, like pandas, is not a core part of the Python library. Therefore, we have to download it manually using this method. Luckily, in Google Colab, most of the Python libraries are added, so you won't really have to worry about it. So Matplotlib is built in for Google Colab, so that's a good thing. We'll be using the matplotlib.pyplot class, when pyplot maintains an internal state in which we can we can build visualization step by step. So what this means is it's the main plotting function. So you have to call this to plot something. And next we just import the library, and what we do is from matplotlib import pyplot as plt, which is pretty much the same as import matplotlib.pyplot. Notice how we replace import with dot as plt, and it's the same thing. I can run both of them. It'll do the exact same thing, and I'll just run them over here. So let's move on to the methods in Matplotlib. So just giving you a disclaimer, you don't have to worry about this stuff too much because it will come to you very naturally when you keep working with it. And these two methods are not independent of each other completely. They actually go hand in hand most of the time. So it's very useful for you to work on this. So yeah, using the basic matplotlib command, we can easily create a plot, which is the matplotlib.pyplot dot plot, which I'll show you here. Remember, if no plot was displayed or if using matplotlib from within a Python script, don't forget to add plt.show at the last line to display your plot. This is the same case for Google Colab. Sometimes Google Colab doesn't really print. So what you have to do is when you make a plot, you just have to add this at the last. And these are the 5 steps where it's plt.plot, which is matplotlib.pyplot.plot, and you put x, you put y, and then you put the styles. There are a lot of styles out there, and we'll talk about those more as we go down the workbook, the notebook. So the next step we did over here is plt.x label, the third is plt.y label, and inside we just put a string of text, which is the label. We all can also set the title, which is the same. There's just a different way to call it. And then lastly, we use the plt.show method to display it, like I mentioned before. So the next method is object-oriented programming. So it's actually another way to create a plot, and the idea is simply to create a figure object and call methods of it. So to create a figure object, we simply use the dot figure method over here. And once we create a figure, we just need to add a set of subplots to it using the dot add underscore subplot method. So for example, over here, the first thing I do is I declare a variable called fig, and I equate it to plt.figure, which creates a new figure. Then I set an axis to it, which is basically me saying add a subplot. And with the placeholder over here simply means the position in our row and column matrix. Don't worry about this. I'll show you an example of this down the line. So it'll make more sense. The third step is axis.plot, which is after that is pretty much the same as this, where we just follow these methods. And what we're doing is instead of just calling this to the whole figure, we're calling it to a specific subplot of it. And again, like I said, don't worry about it. When we're working through it, it'll definitely make more sense. The code, like I said, might not make sense right now, but we'll go through these methods step by step. For now, just remember these two methods, the output is really the same. There are a few just more add-ons in the middle where it's more according to our requirements. But we can use them side by side with the program because, again, the output is supposed to be the same in the end, pretty much almost the same. So you've learned pandas in the previous week, but you haven't learned visualization with pandas. So that's the cool thing about pandas. It's a multi-use library where it also has a visualization method built in. And it's actually what it does is it takes the functions inside Matplotlib and it integrates those functions with pandas data frame and series structures. So the reason we'll be using pandas for most of the work built on Matplotlib fundamentals is because it's a very basic tool with limited features, and it's because its main feature is to draw simple plots that involve numerical data. For example, if it's not good for implementing string values. For example, if I were to plot, it wouldn't make sense, right? If I were to plot, let's say, the names. Let's say that I have a column of all the names of the students in this class. How do I plot those? There, you can plot it using histogram, but when you're plotting bars and scatter plots, it really doesn't make sense unless you convert it into numerical data, which we'll learn simple implementations in the future, but now we don't have to worry about it. So yeah, so the type of plots you studied, we'll be looking into our line, bar, box, scattered, contour. We'll be also looking into legends, titles, and tick labels. And you might have noticed that I've mentioned the types of plots at least 3 times by now. And this is because these are very fundamental concepts to understand, and most complex graphs of history are built on top of this. And with pandas, we have multiple columns of data, as you know, and it has built-in methods for simplifying and creating visualizations from data frames and series. And it does this by using features from Matplotlib and adding new methods on top of them. Another library is Seaborn, which we'll learn later in the curriculum, in the course, but right now you don't have to worry about it. So one of the biggest benefits of using pandas is the method of loading data files as a data frame, and this makes our work efficient and saves us more time to play with the data set. So the whole goal of these libraries is actually to make your life easier instead of using complicated old methods that for which you would have to understand a lot of things before you start applying them. So these libraries are very easy to use and easy to integrate. So we've already talked about what a data frame is before, but let's go into it a little bit again. So data frame is a two-dimensional data structure, and data is aligned in a tabular fashion in rows and columns, as we've seen before. And features of data frame are that potentially columns are of different types. Some can be integers, some can be objects, which are usually strings and text. It's mutable. That means you can change it. You can remove rows, you can remove columns, you can change values. It's very easy to do. And sometimes some things like tuples are immutable, so you can't really modify them after you've made them. And the last thing we have are, sorry, the second last thing we have is labeled axes. It's easy to label them and remember, which visualization represents which column. And you can also perform arithmetic operations such as plus, minus, multiply, remove values, change values. Okay, so now that we've understood what a data frame is, let's load a simple file. This is the URL of our data set. I've shortened it so it's easy and it's not confusing for anyone, but this is simply where our data frame is located. For example, I'll show you. If I open this link in a browser, you'll see this is our data frame. So like I said, CSV, the comma separated. So this is our data frame. So over here, I simply just loaded the data frame. And over here, what it did, it plotted all the columns inside our data frame. So the first line of code is a defined variable URL, which is the link to our data set, as I showed you. The second line of code loads our data set as a CSV file. And in this case, df is what we define the variable as, our data frame as. So pd.readCSV is a built-in function that helps us load CSV files specifically. And inside the brackets, I just declared the URL. On the third line is a new thing where it's df.plot, where I'm selecting the data frame and I'm just plotting it, and it plots all of it. But notice something, the graph is really not correct. The y-axis might be correct, but the x-axis doesn't make sense because they're not dates, right? What is the x-axis representing? One thing easy to tell is that it's just representing the position of that item or that row inside our data frame. But that's not really useful. That doesn't help us get what we want. And we'll look into this more in the future. So let's talk about series. A series has the same structure as a data frame. The main difference is that instead of multiple, there's only a single column. So if we were to plot columns individually, we would be plotting series. And I'll show you a quick example over here. So in the plot above, here are some important things we should observe. The series object index is passed to Matplotlib for plotting on the x-axis over here. Like I said, by default, it over here, I'm just confirming the fact that it is indeed our index that's being plotted. In our case, our object is dfaa, which we declared over here, and which is a column name of our column name in our data frame. And the x-axis and y-axis properties can be modified by using xtick, ylim, ytick, and ylim. But we'll talk about this more as time comes. You don't have to worry about this right now because it's a part of the notebook. But yeah, like I said, now we've confirmed that it's the index. We know that the x-axis plot is not correct. It's just not useful. We don't know what to do with it. So over here, that's where the part comes in. Since we know that our let's look at our data frame for starters. Okay, so this is the index, but there's another column over here. There's something strange about it, right? So we have an index column at the far left of the table, but right next to it we have a date and a time column, which hasn't been named and has a column value 0. What this means exactly. So yeah, what this means is that the column doesn't have a name assigned to it. And what exactly happened when we executed the read underscore CSV function is that since, if you remember, let me just show you a quick thing. Okay, all right, this should actually give you a better insight about what's exactly happening. So I'm loading the data frame over here, but if you look, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Over here we have 1, we have 2, 3, 4, 5, 6, 7, 8. I think I'm okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 9 columns, and we have we over here we have 10 columns, but only 9 names. So there's one empty one over here right before the comma. And since that one was empty, so what happened over here was that was given an unnamed integer of 0, which means it's a zeroth column. If this didn't have a name, it'll get probably it'll get the first number 1. Anyways, so yeah, so we know this that the column at index 0 can be an index column, and this is possibly why it wasn't really given a name, because it's supposed to be the index column. This is a very big reason why a lot of them, leave some columns empty, a column empty in a data frame, because they want that to be the index. So yeah, this can be easily fixed, and what we do is we will just run the pd.readcsv again, and this time we'll make 2 changes. We'll add an index underscore column, but it's called a col and equate it to 0, which means the 0th column. And we'll also add another parameter. So what 0 does is signifies we want to assign the index to the column with ID 0. And what we do is we also add another parameter, which is parse date. Why? Because this is a date. How do we work with this date? Because when we load it, if we just declare it as index, it will be a string. It won't be anything else. So we want it to be a date, so we can actually use it as a base as an x-axis variable for our for our plots. So what we'll do is there's a parameter in built-in read CSV where we just say parse dates and we say true. And yeah, so let's just run this and see what happens. Okay, so the data frame is we run and look at that. So since time is 0, 0 for all of them, it'll just remove time, but we know the dates are unique. So what it'll do is the dates are the index now. That's the simple thing about it. And this is what we want. This is how we should supposed to go with it. We look on how we want our data frame to be before we visualize it. We set it up accordingly first. Let's look at the data types. Self-explanatory. This was something obvious because we have all floats into decimals over here, which are floats. An index column won't be shown here because it's the index, so it's never shown. But it'll be a date format. Okay, so now we're done with the pandas part pretty much on loading our data set. Now we move on to the plotting part. And we start off with figures and subplots. So we know how to make a simple plot for a data frame in a series as I showed above. However, in most cases, what we'll actually have to do is we will be plotting, we'll be plotting series style where we're plotting them individually and seeing them. So for this, and sometimes we want to plot multiple, we want to have subplots and we want different plots to be on each of them. So just so we can, look at them in a better way and it's more easy to navigate through instead of just doing them individually in different blocks. So for that, we use the plt.figure. So what we're doing is, remember, this is matplotlib.pyplot, and inside the pyplot method, we're calling the figure. In the pyplot class, we're calling the figure method. And we're just giving it a figure size of 20 by 10, which is pretty much just, it's just the aspect ratio that we want to maintain when we want to print our graph. Note that this won't really actually print anything right now. We just declared an object called figure, and inside figure, we'll start plotting things. So yeah, let's dive into plt.figure for starters. And now over here, if you look at the object-oriented method that I declared over here, so I added a subplot right over here. So what we'll do is, well, we're simply declaring a new variable and we're adding a subplot to our figure plot. So if you look over here, let's see, where was that? Yeah, over here. So we say ax1 is a variable and we equate it to figure.add subplot. And we say 2, 2, 1 and bracket close. So what's 2, 2, 1? So what the above code basically means is that we are transforming our original figure to a 2-row and 2-column figure and replacing the plot ax1, pardon me, to the first row and first column. In total, this means that there will be 4 plots of which we have selected the first. So if we create the next 2 subplots, we'll end up with a visualization that looks like, I'll show you. So let's just run it through. Okay, yeah, this is an empty one. It's because this is the first, it will only show the first one because the other 2 haven't been filled yet. So now we'll declare 2 more and we'll just fill them up. And when we run them, you'll see that now we have 3 empty graphs. We don't have anything in them because we just declared empty subplots. But let's move on a bit down. Now we move on to the next function, which is the plt.plot function. So initially we use plt.figure and build on top of that, we can use plt.plot function, which is basically Now, this is the part where we plot on a plot. And I've shown you a quick introduction to it before, but now let's dive into a bit more and how it actually works using the data frame. Okay, so we plotted this. And the above plot is a function method. Above the plot is a function method, and inside we define the parameter to be the data frame, the name df, and in the column AA. And once we run this command, it just plots the column with respect to the index, which is now the date time, if you see. If you run all these commands together, you'll get a better insight, where what it did was it placed, even though we didn't declare the plot to be a part of this, it placed the plot automatically over here, right? And this is something by default. So for example, what if I did AX2? It'll take this spot. So if you do PLT by default alone, it'll just take the last available column, or the last available plot, pardon me. And if we declare an axis specifically, like AX2 over here, then it'll take that specific axis. So this is useful when we're arranging our data where we want it to be. So next, let's move on to, yeah, so like I mentioned, if we use PLT, it'll just take the last spot. So this is a now try this method. You should attempt this. It's built on top of what we did before. It's very basic. I've added a hint for the output, and this is what the output should look like. So see if you can match this one. And you can take 2 to 3 minutes for it, and I'll move on to the next one in the meantime. So yeah, the next thing we do is we talk about is colors, markers, and line style. So you've probably noticed that the main function we're using for Matplotlib is the plot function. And what this function does is it accepts arrays of XY coordinates and optional arguments such as color and line style and figure size. There are way more, but these are the fundamental ones, and these are the ones we'll be discussing. So these two are exactly the same. The only difference is over here, we call all of them as one. And that's the smart thing about this method, that it understands this. It knows when all of these are together. And if you declare it like this, it'll know what you're talking about. Or if you want to be more simple, you can just declare the line style individually and the color individually, but they'll output the same thing. Um, what I can do over here is, yeah, so I'll show you this example. So but before that, let's talk about markers. Markers are something important because markers basically point out where the points in your graph are, like what points did you exactly use. This is because when you actually plot line plots, what happens is the algorithm and the backend just automatically joins the closest points. So x1 gets attached to x1 gets attached to x2 from uh, from the and the closest line that can possibly be made. It measures that and just makes it. So we won't really know where our points are. Luckily, marker, what it does is it helps us distinguish. So let's just run it over here. Right. The figure size is small, and this is where fixed size actually comes in. So I wrote this over here because if you want to display it more clearly, we can just run this. Look at this. So the O's are a bit too distinguished because of the thickness, but look at the X's. It's a very dense plot with a lot of values next to each other because it's like skipping. It's every 2 3 days and for the stock market values. So it's a bit hard to distinguish. But if we increase let's say, if we increase the size of the chart or if you break it down, it's going to be very easy to actually understand what these markers are. So I'm just going to remove this for now. But if you want to, view it better, you can just put this in there. Let's see. So okay, so the next thing would there's an extra thing called draw style, which is basically how you want the points to be connected. For this course, you don't really have to worry about this, but I've just added as an extra information if you want to work with it. And for this, now try this. Just try and implement the methods that we learned over here and use them for two plots and try to get something like this. And let's see how that works. There are some specific parameters like that you have to use, so just be careful of those. And you can take like 2 to 3 minutes for these. You can pause the screen while you're doing it, and then I'll just move on to the next one. This is also the hint I've added, by the way. Okay, so this is a little. This is also very useful. Text labels and legends. Again, the purpose of all these methods are how clean do you want your visualizations to be? How much of them do you want to understand? Like you should know what you're trying to look for, right? And if you start off with not knowing, you use these methods to make it easy to observe the plot. So let's talk about text labels and legends. So the PyPlot interface designed for interactive use consists of methods like xtext and xtext labels. These methods control the plot range, the tick locations, and the tick labels, and there are two ways to apply such parameters. So you can call it with no argument and return the current parameter value, for example, plt.xlim, which returns the x-axis plotting range. I'll show you an example right under this. And the other method is called with parameters set as parameter values. For example, you give it a range from 0. I can either give it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or I can give it 0 to 10. And if I just give it the values directly, it'll assume the same thing. The only difference, it's a very simple difference. So if I don't declare this, if I don't declare the list, it inside the list, what it'll do is it'll just print, I'll show you an example right now. How about that? So look over here. So right now, what I did was my range should initially be 1, 2, 3, 4, 5, 6, right? This is how I wrote this. So I wrote 1, 2, 3, 4, 5, 6, and then I wrote y, which is pretty much just the double of every x number. So if I keep increasing this, it'll be an exponential graph that just goes like this, like this. So, but over here, I'm adding an x limit. And the new graph is restricted between 3 and 6, right? So that's the interesting part. So if we want to cut out pieces of a graph, we can simply just do this. And one thing that we'll do over here is, yeah, so if I add a list, if I just put this inside a list, it does the same thing. So there's really no difference between them. That's the interesting. That's the helpful thing about these. So it's very conscious of if you make mistakes or miss out something and adjust accordingly. So as you can see, the X limit is very easy to set up using the plt.x limit. However, when working with the time series data, such as the stock market one, simply stating plt.xlim 2005-2008 won't actually work, nor will if you even declare the month, the date, the specific dates. It won't actually work. You can try it out. Let me show you an example. So I have this over here, and I do this. It'll give me an error. Let you know in advance because it doesn't know. It doesn't know what kind of format is this. Uh, Luckily, what we do is again. Let me just remove this. Yeah, so luckily what we can use is import datetime library, which is very useful for when we're trying to segment our graphs, to get specific areas. So I just import it. And what I do is from that, I use datetime, which is a library, and I use the method date inside it. And inside, I just declare 2005, the month and the date. And then I give it an ending range with 2009, the month and the date in case it's 1-1. And then let's just plot it out. Look at that. So we got 2005 to 2009. From the outside the whole graph, we could segment that data out. And so let's talk about the method quickly. Above, we are importing the datetime in the first line, and next we plot our data frame column. In the third line, the first thing to notice is the datetime.date method. And this takes three parameters, which is the year, the month, and the date. And in our case, it's 2005, 0101, 2009, 0101. Fairly simple. And so now we know limits. Let's move on to title, axis labels, and ticks and tick labels. So the way these modify your graph is basically this is like extra documentation for you. So you know what you're looking at. You're labeling your graphs to make more sense of it. So let's start off with a simple plot and then we'll work on top of that. So this is a simple plot we talked about before. I declared a figure size bigger, so it's just easier to navigate through. And we're going to add xticks, and it's easier to use xticks using set xticks and set xtick labels. Remember, this is an axis. This is a subplot. This is not the main plot, right? Over here, I added a subplot, so I'm working on the subplot. The implementation for these are very easy, to be honest. All you have to do is when we're using PLT directly, you just don't add this part to it. This is not a part of it. You just write xticks. But anyway, so let's work on this. So the first thing I do is I add labels where I say label equals to ax dot set underscore xtick labels. and I give it a range where I say 1, 2, 3, 4, 5, 6, 7. I give it a rotation of 30, and I say the font size needs to be small. These are built-in methods. I've given you most of them over here, so you won't really have to go through the documentation. But if you ever want to, they are there, so and they're very helpful to look through. So let's run this and notice a difference. Oh wait, let me just. Okay, so right now I've just actually. Okay, yeah. So over here we have 2, 3, 4, 5, 6, 7. The thing is, this is the zeroth axis. So this is where 0 starts from. So it's leaving a gap over here. Rotation is 30 and the font size is small. Uh, let's try. Yeah, so I can keep it as large and it'll give me a bigger one. So fairly simple. For now, I'll just keep it small just for your reference. And yeah, that's what it does. It helps us document it further the way we want to. Before um, it was just the datetime. So next thing we do is we do ax.setTitle, where I'm just going to add a title to it. So let's see. And there it is, my first Matplotlib plot, which is ax.set underscore x, ax.setTitle and my first Matplotlib plot. And we just write figure to display it. Then let's do it for an X label. Okay. So now we have stages over here, which is what we wanted. We use set underscore X label. And okay, so this is something that interesting I'm going to do where I'm just going to add another graph to this directly. I'm not going to plot it on another axis because I haven't really declared another axis over here. I only have AX over here. So and it's a 1 by 1, so it's just one image. It's a one plot graph, sorry. So let's just plot it and see what happens. Okay, so I have two plots in there now, but everything else is the same. Nothing else changes because I'm adding on top of it. If you want to make your life easier, this is a way to go with but you don't have to worry about this. This is just a method. I got accustomed to writing these, so I use this now. So this is a now try this method. You'll be using the what you learned previously. So you can so the good thing about this notebook is there are not that many questions. There are about 7 questions, so we can give you more time for those. So just read the prompt and just follow the steps. I think this should be fairly simple. You can pause the screen while working on it, and in the meantime, I'll just move on to the next one. Again, I provided hints on how it should look like, so just try and follow that. Adding legends. So legends is basically I'll show you an example where it's very useful for DF.plot. Where remember when I first flipped, this is what a legend is, and PLT DF.plot, when you're plotting the whole figure, it does it very easily for you. But when you're plotting them individually, you have to add this option which shows you the legend. So I'll show you over here. So plt.legend is just this. So right now, let's go through this code, okay? They're a very important element because it helps us identify what's in our graph. And let's just do it. So we declare a figure over here. We add a subplot. And on the subplot, we say this is the column we want to plot. This is the, and again, if there's no y provided, it'll take if there's no x provided, it'll just take the index as the x-axis, which is exactly what we want. This is the color, and this is the label I'm going to add to it. Same thing. The column red is the color. I want it to be double dashed line style. And then lastly, I use this column and I add G, and I want it to be dot style, and I'll just add the label GE. So let's run it. Okay, this is cool, but how do we know what they represent without looking at the code? We don't, right? So here's what we do, and we add this over here. Look at this. So Microsoft is blue, Apple is red, and GE is a dot and it's green. And we also have the line styles. So it's very easy. So usually you should go with best because it just chooses the best location and just puts it there. Otherwise, you can just, even if I do this, it'll work the same. And right now, it'll just choose the best by default. But I was just trying to show you what it does. So we can leave it like this, actually. Let's just do it again. Okay. Yeah. So this is what it does. And let's move on forward. So one of the last steps before we move on to the relational graphs is saving plots to file. and it's simple. It's just one line of code where you just plt.savefig and you just give it the name and the extension, right? So for example, if you use .pdf, we will get a PDF, but it wouldn't make sense for an image and a graph. Actually, it would you can get it as a PDF image, which is fine. But JPEGs are more useful if you want to put it somewhere. PDFs are big documents. You can just simply run this, and I'll just run this, and I'll show you what happens. So the figure is saved, and I have it right here. So you can do this whenever you want to save your graphs when you're working on projects, and try and do the what we did above. Very simple. And just plot it out and see if you can get this output. All right. Good luck. And you can pause it, like I said, and I'll move on to the next one. So now we've covered the basics of plotting. Let's move on to the types of graphs and charts. So for starters, we have bar graphs, and this type of graph is a good choice when we want to show some quantity varies with respect to some set of items. And items are usually strings because that's where bar graph works. It's good for plotting showing quantities, like I said, like X is this much, Y was this much, this many apples, this many, bananas, stuff like that. So a simple example that we've made over here is we have these movies: Annie Hall, Ben Hur, Casablanca, Gandhi, West Side Story. I got the example from a book, so I think the guy was very old fashioned. But and these are the number of Oscars they won: 5, 11, 3, 8, 10. So I do this, and I do plt.bar, and I declare the movies as my x-axis. I declare number of Oscars as my y-axis. Just for reference, I'm adding a title and a y label and an x label, and let's see. And there you go. So Annie Hall is 5, Ben Hur is 11. So you can see the pattern. It plots out quantity. In the code above, movies is our x-axis, like I said, and our y-axis number of Oscars. And to plot the bar plot, we use the plt.bar and we declare the xy inside. Okay, so this one is going to be a fun question, actually. I want you to read the prompt and attempt it, and you have to write an if-else condition over here, right here. Very easy, shouldn't be difficult, but if you have any questions, it just read the prompt, and I think it should help you out. You can pause the video again while working on it, and I'll just move on to the next one. And this is the output you should be expecting. So see if you can imitate this output. As an extra, if you want to work on this, try and convert the columns into a pandas data frame, because it's useful because for the type of data you'll be working with. And another good use of bar chart can be for plotting histograms of numeric values, and this helps us visualize distribution. Now, histograms are a very important part of data analysis, but why is this? So this is because a lot of times we want to count the frequency of something. We want to see what are the repetitions of a specific item inside a data frame or inside our data set. So for that, we use histograms. Luckily, we won't really have to manually set up plots when we're working with data frames. The previous information was more so you can actually understand how it functions and know. And we can just declare a column we are using inside the plt.hist method and define the column inside as df apple or whatever we want to make. We also make another parameter, which is the bins. And bins is basically the number of columns you want our x-axis to be divided into. For example, if your x-axis is 0 to 100 and you declare bins as 10, so 0 would tend to be would be enclosed in one bin, 11 to 20 in the second, and all the way to the 10th bin, which would be 90, which would be 91 to 100. Yeah. So I used 20 over here. So we're just going to print this. And there you go. So we have 20 bins over here, and it's showing me the frequency of the apple stocks. Like the low values were more high in quantity than high values, right? Which makes sense. I mean, that is a specific, we have it from 1990 to 2016. So there's a rise, but it started off pretty low. So that's where most of the values were. Apple really shot up, I think, in the mid after the iPhone, definitely. Before that, it was still a bit flimsy on its value. So low on its value. So this is what indicates that. Now try this question. You'll be plotting a histogram, and this is what you should be getting. So give it a try. And let's move on to line charts next. So this is it's easy to make line charts using plt.plot because that's what it does by default, as I've told you before. So let's just run this. Okay. We added a marker. We added a solid line style, which is actually by default too. So if I remove this. I see the difference. Yeah, it's the same. So we have the color equals to red, and we're using years versus GDP of any random country. And we add the title and we add the label and we just plt.show, which shows it. So over here, you see we're not declaring axes, we're just plotting it directly. And next, I'm going to show you a quick another example of how line charts work. Over here, I've created a list of 0 to 5 with increments of 0.5. I'm going to create another list from X where I'm going to say for every value in X, multiply that value by to the, do it like to the power of 4. And whatever the output is, save it in a new list called Y. So 0 to the power of 4 will be 1. Then 0.5 to the power of 4 will be, I do not know, but that's why programming is there to make your life easy. And then what I do is like after I'm done with Y, I create another list. And again, this is me just having a little bit of fun with this. It's not something really necessary, but it's useful to understand. It will definitely help you a lot in the future if you understand what lists are and how to make list comprehension. What I'm doing is for every value in Y, I'm dividing it by 3, but I'm using a double division sign to make sure it's not a float, but it's an integer. And once the list is made, I'm just flipping the whole list. I'm reversing it. So let's run it. All right. So this is our plot. It doesn't have any titles, labels, but of course you can add them over here to make your life easy. But yeah, so this is just illustration of line charts, so you can have a better idea. Let's move on to scatter plots. A scatter plot is the right choice for visualizing relationships between two paired sets of data. We can simply run a scatter plot by defining two lists and simply run plt.scatter. It's the same for additionally you can simply add styles such as color, line style, or all the methods we previously used to make the graph. So let's see over here. I'm just going to do a quick scatter plot where it's trends versus the minutes. They're arbitrary, so don't worry about it. Okay, so yeah, the number of minutes spent on a website versus the number of friends someone has, and we can see there's a correlation. So if you have more friends, especially after, let's say, that's where well, the last two are higher, so I think that gives us an idea about it does increase with increasing number of friends, the time you spend on the internet. So when working with data fits, the analogy does not really change. The only difference is that instead of directly inputting lists, we'll be using df column name for both x-axis and y-axis. So this is another, now try this section where try and imitate this graph and see if you can plot it. Fairly simple. So I'm telling you to use this just so you have a better idea on how it actually works. Again, it'll just take the index by default if you don't define an x-axis, but just try and do that and see what happens. And now we're going to move on to the tutorial. So that was the last question you had to attempt in this notebook. Now we'll be going to a tutorial, which is working with the California housing data set. If you don't remember the information we talked about earlier, you can just click the link over there and you can go back and just read it quickly. And by this point, we have learned how to use Matplotlib, basic pandas plotting. And in this tutorial, we'll be focusing on analyzing the housing data set just by simply mapping it. We're not going to get any insights. We're just going to simply map and see how far we can get. The perk of this exercise, the main thing is that you can just do the whole thing by using one function, which is the df.plot method. And it's also very important to note that our limitation is restricted working with numerical data in the kind of plots we're trying to do. Because it's Matplotlib can't exactly plot categorical data. Pandas does, but for this tutorial, we're going to keep in numerical specifically. So I'm going to just import these again. We don't need this. Plot SPLT. And I'm just going to import them again. They're already in the system, but why not? And this is me just downloading the URL. So I will just show you again what the URL is. And there you go. So this is our data set. Over here, we don't have an index, NMT column. So that means, the index will be what Pandas sets by default. So let's load the file and just observe it. Okay. Numerical, only the ocean proximity is categorical. Other than that, all of them are numerical. So each, I think something about about the data set is that each row represents a district from California and whose data was collected. So it's a pool of a number of people they talk to, but every row is for one district. And there are 10 attributes: longitude, latitude, housing, median age, total rooms, total bedrooms, population, households, median income, median house value, and ocean proximity. So let's look at the info for this. So you have 20,640 total counts. And but over here you see is one of them is null. So all attributes are numerical except for the ocean proximity field. And its type, if you see, is object. And what this means, it can hold any kind of Python object. But since we loaded a CSV file, it's a text file, it's a string. So when we looked at the top 5 rows, we probably noticed that the values in the ocean proximity column was repetitive. If you look here again, you see near bay, near bay, near bay, which means it's probably a categorical value. There is a way to convert categorical value into numerical, where basically what you do is, let's say I have three house values and two apartment, for example. I can just say house is 1, apartment is 2. And if there's another one, let's say boat can be a new number 3. So that's what data scientists usually do when they strictly want to work with numerical, but they want all columns to be there. They just convert into that. So let's look at let's look at the description. So the count, mean, min, max values are very self-explanatory, but the null values are ignored if you look over there. So because when it's printing the total bedroom values, it's printing 20,433. It's not printing 20,640, which means it just ignored the null values. The standard deviation row, the STD row, shows how dispersed the values are. The 25%, 50%, and 70% show the corresponding percentile. A percentile indicates the value below which a given percentage of observations in a group of observations fall. For example, 25% of districts have a housing median age lower than 18, while 50% are lower than 29. If you look over here, 18, 29, while 75% are lower than 37. These are often called 25th percentile or first quartile, the median, and the 75th percentile, which is also the third quartile. And another quick way to get a feel of the type of data we're dealing with is to plot a histogram for each numerical value. A histogram shows a number of instances, as I mentioned, the count, that have a given value range on the horizontal axis. And we can plot this one value at a time, or we can just call the HIST method on the whole data set. And we'll just look at it below. So let's start off. To visualize our data frame, we will execute the following code. And let me just execute this, and then let's talk about it. Okay, so this is the plot we got. So the first line was importing pyplot. We already have it there. I just did it again just for a bit more information. Housing.hist, which basically means we're plotting everything unless we declare a specific data frame inside. We declare the bins as 50, which basically means we want it to be divided into 50, bars. And we declare a fixed size of 20 by 15. And lastly, we just do plt.show. Like I said, it's important when you're trying to plot it, otherwise I wouldn't plot it. So if you observe the histogram over here, there are a few things about it. Let's look at the median income. The median income is over here. So it's not represented in dollars. It's basically normalized. And normalized, I'll tell you about what normalized means, but let's just talk about the data set first. So the data scale is actually capped at 1600. Sorry, pardon me. It's capped at 15 over here, where it stops over here. If you look at it specifically, it stops at 50.0001, but 15 is what it is. So for higher median incomes, let's look over here. It caps at, let's see, where is it? It caps at pretty much. So for higher median income, it is 50, and for lower median income, it starts from 0.5. It's not something from plain observation, but I think you can get a general idea. 0 to 2, this is where 1 is. So this is probably 0.5 or something close to that. Actually 0.4999, but these numbers represent roughly tens of thousands of dollars. Example 3 actually means 30,000, and this kind of data is common, but we should try to understand how the data was computed. The housing median age and the median house values are also capped, which means if you want to find patterns beyond 500,000, so it caps at 500,000 over here. So this is an issue because it gives us a restriction in our data set. So either we have to collect more data from the districts whose label were capped just to get a better idea, or we remove those districts from the training set or incompletely. These attributes have very different scales. This means that one might be scaled to 1, while another might be scaled to 10. Uh, so what scaling basically means is that think of numbers from 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, what will happen if you divide all these numbers by 10? The result will be zero point 0.1, zero point 0.2, zero point 0.3, zero point 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 10. So all these numbers are within the range of 0 to 1. So if you divide a range by the largest number, they'll be scaled down to 1. Uh, Many histograms are tail-heavy and extend much farther to the right of the median than the left. This is not a concern, but it's a tricky situation as it is difficult to detect patterns, particularly through visualization. And then you have to work on the data a bit more. But this doesn't happen that uh, it happens for histograms sometimes, but it is still not as common when when you're working with a bit more structured data. So let's print a specific histogram. We're going to print the housing median income dot hist, and okay, and we're also going to print the categorical, which is ocean proximity, which shows the count of all these categories. So there's no island, but there are a lot of one that are close to the ocean. Uh, Actually, there some are near bay, some are very close, some are inland, and some are near ocean. So let's plot this and just make a quick scatter plot. Yeah, so this is we're just making a scatter plot of the housing of the median income versus the median house value. Don't worry about this. This is just so I can show you something, but we'll talk about this more down the line. This plot reveals a few things. The first is the correlation is actually very strong, and we can see an upward trend between as median income increases, the median house value for people also increases. And there's also a price cap which is at 500,000. You can see that line over there on the top. But there are also a few more lines if you notice. So there's a line at 450,000, there's a line at 350,000, and probably one close to 280,000. So these indicate something that there are points where the housing median income kind of stagnates no matter what your median income is. As long as let's say it's below 6, but if it goes up to let's say 8, then it increases. Okay, so now is we talk about mapping geographical data, which is where the longitude and latitude part comes in. So let's just simply plot a scatter plot where we're using the longitude as the x-axis and the latitude as the y-axis. Remember, longitude is always x, it's horizontal, and latitude is always vertical. So when you plot it, is what you get. So by plotting the longitude versus the latitude, we can see that it's California. However, note that it's really impossible to see any particular pattern. The next step is to be able to separate the high density data points from the lower points. For this, we'll use the alpha option, which I mentioned earlier. But for now, we'll set alpha to 0.1 just to see what happens. So what is alpha? So Matplotlib allows us to adjust transparency of a graph plot using the alpha attribute. If you want to make the graph plot more transparent, then we make alpha less than 1, such as 0.5, 0.25. If you want to make it if we want to make it more transparent, then it's less than 1. If you want to make it less transparent, we make it close to 1. And okay, so I declare alpha is 0.1 over here, and I'm going to run it. Do you see the difference? We can see the difference between the high density areas, for example, the Bay Area, Los Angeles, San Diego, and a little in the Central Valley. But it's still really not useful. We don't really know what to get out of it. Of course, it was very obvious that these places are high density. So let's move a step further. So over here, I'm adding about 1, 2, 3, 4 new parameters. Nothing to worry about, very basic parameters. And when we plot them, this is what we get. Okay, so let's talk about these 4 little. Remember, we're only using the Plt Plot function. This is because Matplotlib or PyPlot features are built in Pandas. So we only call Plt Plot. It's very similar to the Pandas function. The main difference is we directly identify x, y, and instead of Plt, we connect our data frame. So let's look at what we're getting over here. Big size is something not necessary. I just declared it there because I wanted a bigger size than this. So I just declared figure size inside. It doesn't hurt to add it. C is basically it defines a column. It defines a third parameter inside our plot, and it what it does is we are going to color the we're going to add a color, and that color is going to vary based off the value. In our case, it's the median house value. The next thing we do is we give it a color palette where I used so next time you use this, you just simply copy paste this. This is something built in. And what you do is I declared a jet. There are other ones available too, but jet is the standard one and is simple for classifying. Last thing we do is we set a color bar, which is we want to see this. We want to see what the prices actually indicate. Um, yeah, so this is the next step, but there's still we can get more out of it. So we're going to add one more thing. We're going to add one more parameter specifically and a few parameters to support it. So we know where the median incomes are high. They're high in Los Angeles, and the Strip. They're high in San Francisco, and they're also high in San Diego. But in Central Valley, even though it's dense, it's actually not as it doesn't have a high income value. So the next thing we'll do over here is we're going to see the the housing population in those areas, and we're going to let's plot this first and see what happens. We're going to add population to our graph now specifically. Okay. Uh, First of all, I increase the fixed figure size over here, and now what do we see over here? Do you see the bubbles, like the radiuses? So what these indicate is the population. The bigger the circle, that means the higher the population over in that area in those specific districts. And we can make the plot bigger just to get more idea out of it. But this is how it essentially works. So let's look at the parameters. So the first parameter we added is housing. From the housing data frame, we added the population column, and we divided by 100. So why did we divide by 100? We did it because the value, if we don't divide by 100, this is what it's going to look like. That's that's nothing. That doesn't give us anything, right? So what we have to do over here is we use a number 100, and this is again we're normalizing it. We're normalizing the values to, and we're keeping them like with respect to 100. So I'll show you another quick example really fast. And I'm going to do for that, what I'm going to do is, so the max population we have is this, right? This is not something I would recommend, but it's just to give you a general idea about what it exactly does. And what I'm going to do is I'm going to normalize all of them with respect to this value. So let's see what we'll get. We don't really get anything because they're just so small, because they're normalized to one, right? So they're just really small radiuses. So 100 was a value that's decent. That helps me get a decent size of plots, and I can actually see where the radius is higher. So that's S, where it's a parameter which plots the given column as a radius on the map. And the main reason we chose to divide it by 100 is to make the radius smaller. We also add a label, which is the population. So the label gets added over here. And because we added the label, we have to add a plt.legend over here. Everything is so very simple. So that was your introduction to data visualization. We learned the basics. We learned how to plot data frames using Matplotlib and Pandas. We learned how to make subplots and set axes, how documentation such as labels, legends, colors, markers are added, how to plot bar, histogram, scatter, and line plots using lists, how to plot the latitude and longitude, how to add a third parameter with df.plot by using C, and how to add a fourth parameter, S, to our plots. In the next lesson, we'll be working with Python, Pandas, Matplotlib libraries to create clean uh, to cre- uh, to clean and visualize the data set we'll be working with. That's all from me now. If you're a part of the course, please follow the steps mentioned in the start for the grading and submit your answers. In the end, download the zip file. And thank you.